The next transformation is called rotation. Again, you've done these before in Key Stage 3. You've got reflections, rotations, you've got translations involving vectors, and you've got enlargements. These are the four transformations of shapes. So you move one shape from one position to another by reflecting, rotating, translating, or enlarging. And in the case of enlargements, it's the only case where the shape actually changes size and gets bigger or smaller according to a given predetermined ratio or proportion. So we'll come on to enlargements in due course, I'm sure, if you've not already done so. Yeah, enlargements is in fact chapter 14. So that's a little way ahead then. Right, this is question 4. Not just rotation, but rotational symmetry. Now, if you remember, it's a very low level stuff then. They've graded this at F, so it's not very hard. You've got to copy and complete the grid diagrams to show each one has the order, has the given order rotational symmetry. Now, if you remember, if I put a little cross there, and imagine I'm going to put it like a little stab there, and allow this just to spin round, I've got to fill in this little box here, this grid, so that the shape has rotational symmetry of order 2. Now, if I fill in this square and this square here, it's really hard to teach this except without tracing paper. Anyway, you're going to have to bear with me. Can you see that if we spin this shape once round, that will end up going to that, and that will end up going back home. So within one 360-degree rotation, it would appear as though the shape will sit on itself in exactly the same position twice. So when this goes to here, it will appear as though it's not even moved, but we know we've moved it around half a turn, and then this goes back to its original position again. So we have order of rotational symmetry 2. So now that I've reminded you what the order of rotational symmetry means, I can then try and do this one, this little blue affair here. I'm going to go for that. That sort of looks bluish, so I'm going to go for that one. Now this has got to have order 2 as well, and I mean, forgive me, it's not exactly the same blue, but who knows how it looks on the video. So if I put that there and there, I think I've managed to do that. Let's be absolutely clear. What I'm going to do is fill in this in blue as well. I'm not told how many squares I've got to fill in. If I fill in this little lot here, I've got a 2 by 4 rectangle in the middle of this square, then I take my drawing pin or my pencil, stab it right there and rotate. I've got order rotational symmetry 2. So this part will go around this way and sit on itself again, and then this will go back to the beginning, and that's it. So can you imagine that? It will come across, this will go round, spin around this point just there, and these two end up down here, and then those two go back home again. So that's order rotational symmetry 2. Now there's more than one answer to all of these, I'm sure, but I'm just doing the one that's obvious. Now, order of rotational symmetry 1. Anything has got order of rotational symmetry 1. Even if you have an uneven shape, an irregular shape, and you spin it round once about a certain point, it will go back to itself eventually. So in order for this to have order rotational symmetry 1, I could shade this first square red. Now look, if I was to spin this grid with these red squares about this centre of rotation, say, then what's going to happen is this shape will go down to here, and the red will appear in this corner, but this will be white. So I've not got an order rotational symmetry 2 at all. It'll only become order rotational symmetry 1 because it's got to go all the way around and back again for this little red square to sit on itself. Now these will, if this wasn't here, this will have order rotational symmetry of 4. Okay, but I'm not told to do that. It's got to be a 1, and so therefore, so that should be red. So therefore, this square needs to be red, or anything else needs to be red. Actually, any one square will be fine. Any irregular arrangement of squares would do that. And now we'll do the green one, and we'll see, I think, what's the best match I can do. I'm going for that one. So, okay, order rotational symmetry 4. Okay, I've got a lot to shade in, I'm sure. Oh, it's quite a good match, really. So that one's got to work. I've got to have one in here. Please note, if it's order rotational symmetry 4,
there's something 4 about the way I'm shading all this. So 1 in each corner, that makes 4. 1 around the middle, about which I'm going to spin the thing in a minute. That's 4 again. Now look, I've got 4 in the middle, 4 in the edges. That's going to have order rotational symmetry 4. Back to my black, so put my pencil right in the middle, shade it, put my tracing paper over it and spin it round, and if I spin it round a quarter of a turn, that will go there, that will go there, that will go there, and that will go back home, and that's order of rotational symmetry 4. Okay, study that or look back at your key stage 3 stuff. Now question 5 is quite pleasant. Yeah, very nice. This might take 2 videos actually. Yeah. Right, I quite like this question, I have to admit. Let's just work in white here. It says the hands of this clock each turn through 360 degrees in one rotation. You know that. All the way around there, 360 degrees full turn. The hour hand turns through an angle of 180 degrees from 12 o'clock down to 6 o'clock. You know that as well, don't you? Now, write down the angle the hour hand turns clockwise through. No, read again. Write down the angle the hour hand turns clockwise through from 12 o'clock for each of these times. Very complicated English. What that means is from 12 o'clock to 3 o'clock, what's the angle? Well, let me just take a little bit of black there and dot it across there. That's 90 degrees, isn't it? So that's going to be 90 degrees. You know that, quarter of a turn. B, from, this is tricky, from 12 o'clock to 11 o'clock. Let's just do a quick calculation here. It's not 360, it's not a full turn. Now look, we got 360 degrees and we got 12 whole hours. So 360 over 12 hours, that goes in there 3 times. So every 5-minute block of time will be an angle of 30 degrees. Okay, so that's for each 5-minute time interval. Right, so that being the case, let's go back to doing the time. So I've got basically for 11 o'clock, I'll go around here clockwise because that's what clocks do. Hit 11. Alright, so I'm going to go all the way around here, hit 11. So I'm really 360 degrees less 30. So that's 330 degrees. Alright, so it's 30 less than 360. Now, from 12 o'clock to 9 o'clock, going around this way, so that's that bit there. That's 3/4 of a turn. It's 90 plus 90 plus another 90. Or, if you want to look at it this way, it's 360 take away a quarter of a turn. So that's going to be 360 take away 90 degrees. That's going to be 270 degrees. Now 4 o'clock, that's that one. Goes around here. We've got 1, 2, 3, 4 sections of 5-minute blocks. So that's going to be 4 lots of 30, 120 degrees. And from 12 to 8 o'clock, so from 12 to the 8 goes across here. We want all that little bit there. So 1, 2, 3, 4, 5, 6, 7, 8. 8 times 30, 240 degrees, excuse me. Okay, not too bad, is it? So that's that, and I think I'll do one more and then pause for a second section of this video. Right, more rotational symmetry. It says for each part, write down the order, write down the order of rotational symmetry and the angle of rotation. Well, this is really easy. They've drawn these shapes really well. So this will go to that. That will go to that, and that will go to that. Order of rotational symmetry 3. If I just put a 3 here, then you'll get it. This one here, very easy. Look, they've got the centre point, the centre of rotation. That will go there, and then we go back home again. As you can see, it will sit on itself twice. Order of rotational symmetry 2. This one, I hope you're getting the idea. That goes there once, 2, 3, and back home 4. Order of rotational symmetry 4. And I've got to do the angular rotation. Well, if it's 360 one turn, then this must be 360 divided by 3 chunks. In other words, each angular rotation must be 120 degrees.
Likewise here, I've got 360 divided by 2 turns, so it'll be 360 over 2, 180 degrees. And this last one here, I've got 360 over 4 bits of a turn, not 4 whole turns obviously, and that will give us 90 degrees. In fact, it looks quite like 90 degrees anyway, and this is clearly a straight line, so angles on a straight line, etc. 180. Now, question 6b. If a shape turns through 60 degrees and looks the same as its original position, what is the order of its rotational symmetry? Alright, 60 degrees. So how many lots of 60 go into 360? I'll let you know, shall I? So I've got 360 degrees divided by 60 degrees. How many chunks of 60 go into 360? The answer is 6 times. Therefore, we've got ourselves a hexagon. Look at this. 1, 2, 3, 4, 5, 6. And this is a freehand drawing. So imagine I'm going to put a little cross there. So let's have a look. That will go there. 1, 2, 3, 4. Oops, missed that one. 5, and that will go to there. 6. So order of rotational symmetry equals 6. And you don't need to draw the picture, but you may recall that's called a hexagon, and it has to be a regular hexagon, otherwise the sides won't exactly sit on top of each other as they go for an extra 6-degree spin. And let's just put a different colour here, because these I'm drawing in freehand. I should use the straight line facility really. All these are 60 degrees, right? All these are 60s. So all these are in fact equilateral triangles. If it's a regular hexagon, all these are 60s. There you go, 6 60s, 360 degrees, and that's quite pretty. I will definitely pause there and study the next bits, and I'll get back to you.